Today I am looking at my old 60s or probably even late 50s twin reflex camera. I cleaned it recently. It has this really cool old mechanism inside for the shutter release that looks like an old watch. So I spent some time cleaning everything out, cleaning both lenses, and the challenge is I don't have a cover for these lenses, so with time sitting in the case, it just gets dusty. So I decided why not make a lens cover for this. The first step that I want to do is take the measurements of my lenses, so I can then carry over the dimensions over into our CAD software and proceed from there. So let me get my calipers real quick. So I have a few measurements that I want to take in order to create this cover. I want to make a single piece, so I don't have to take two caps off independently. I can just take one off, and it will cover both. So the first dimension that I want to take, let me sketch real quick. So we have a top lens and we have a bottom lens. It's not, there we go. So there are a few dimensions that we're looking for. We have the diameter of the top lens and diameter of the bottom lens. And we have center to center dimension, right? We need to know how far apart those two lenses are because we're going to connect them together as one part. So, and one final dimension, I want to know how deep my cover needs to be to cover the lenses. I will go on my bottom cover lens since it's not as tall as the view lens up top. So I just want to have enough to cover the bottom. So I will need a dimension for the bottom lens. Okay, so with that, my preference for dimensions is millimeters. Use whichever units you are comfortable with. So in my case, I use millimeters. Okay, so my top lens looks like 29.9. 29.9. And my bottom lens, same, 29.9. That makes it easier for us to model it down the road. So, okay. Now, I want to find out what my distance center to center. However, I don't want to get my calipers too close to the lenses. They're old. The coating is brittle. So instead, what I will do, I'll measure this distance right here between the two. So my distance between the two lenses is approximately 14.2 millimeters. So that is my distance right here. Right. So in order to get distance center to center, all I have to do is add the radius from the bottom, radius from the top circles, or the diameter. Since they're both the same, it's going to be 29.9 plus the 14.2, which gives us 44.1. So that is our dimension for the lenses. The only thing that I still want to measure is the depth of the top lens, and that ends up being 6.3. I am comfortable just making a 6. So it is 6.3. I'll round it down to 6. Okay, so this makes up our measurements that we wanted to take. All right, so I will set this aside for now. Now my CAD software of choice is FreeCAD. It's a wonderful open source software. Typically, we start off with a screen and a stage. So we'll switch over to part design, and we will create a body. Body is what's required. Basically, body is our part in this case. And we start over with creating a sketch. So we'll select the top, and we start off with a bottom lens. I do my best to put my sketches at the origin. Simplifies the process down the road, especially when it comes to dimensioning your sketches. Make sure everything's fully constrained. So there's our first circle. Now we know that our top lens is in line along the vertical axis of the bottom circle. So it will snap to the same vertical. We see this little icon pop up. Right, and we'll just do this. Now we put the dimension, arc or circle dimension, and we said it's 29.9. I could do the same here, but instead I will shift select two circles, press E, and it will make them both equal. As you can tell, the bottom circle is now this muted green color. That means this circle is fully constrained, and this top one is not. The top one is still free to move in its position. So what I want to do now, we know that our dimension between the two center points is 44. Oops, wrong button. So I select this center point, press I for vertical constraint, 44.1. Now, this two green circles that we see means the sketch is fully defined. All dimensions are the size of the circles, the position of the circles is fully defined. Now, these are representing our lenses, so I cannot use this particular dimension because I need to build a cover that will be larger than the lenses. So what I will do, I will convert these two circles to a construction geometry. Think of it as a reference point. Right? Construction geometry does not extrude into, it does not extrude when you go to the next step. It's there to act as a reference point for your sketches. So now what I will do, I will create a sketch, and I want to add a 2mm wall thickness around the caps, around the lenses, I'm sorry. So that means I need to add 4mm to each diameter, right? So press R for radius or diameter, and it was 29.9 plus 2, plus 4, right? We're adding 4mm to the diameter. So 4, and I will shift select, make equal. So we have now the two lenses covered with its wall thickness. Now if I try to go and extrude this, FreeCAD will not let me extrude it because it's basically saying you are trying to make two parts right now. You're trying to extrude two cylinders that are disconnected. And this current version of FreeCAD doesn't allow that. We will jump back to our sketch, and we will simply bridge the two circles, since I want them connected anyways. Down. We will put a simple bridge in between. I for length, vertical constraint. So let's do 20mm. Length for L length, 10mm, perfectly fine. And I will select this center point. I'll press I again to constrain it to the origin. Now in this point, I have multiple loops, right? So now I want to remove all unnecessary edges to create one continuous loop that will form my cover. To do that, we'll take a trim tool and just start trimming away excess I will not touch the blue circles since those are just a construction geometry and it will have no impact on our sketch or extrusion. There we go. Now we lost the fully constrained, right? It's no longer fully constrained. So it's now a white sketch. To fix that, we will take these 2 points, constrain them together, take this point, constrain it to the origin, and now the sketch is fully defined again. At this point, I can now close this and extrude it. My lenses are my bottom lens is 6.3 millimeters. I want to add 2 millimeter wall thickness, so I'll make it 8 millimeters. So that should be plenty. Okay, so this here is our solid body that represents our cap. Now what I want to do next is remove the materials for the lenses to fit inside. So we jump back to top view. We can by clicking this, or number 2 on your keypad. Let's select our face and create sketch. Nope. Select the face and sketch. There we go. So we can now see that our origin is on top of the face that we selected. Okay, so I will make a circle cutout for the bottom. And I could do this same thing here and then put a measurement, center to center measurement. But instead, I could also take a reference point from the geometry itself and do it this way. And we will say there is a circle there. And this circle is now defined to that position, constraint to that position, I'm sorry. So let's add the dimension. The lenses on the camera are 29.9 millimeters. If I make the cutout 29.9 millimeters, they simply will not fit. So I want to expand the opening slightly, but still keep it tight. With my current printer, the Bambu Lab A1, I can comfortably add 0.25 millimeters to the diameter to have a nice snug fit. That's just based on my testing and trials. So it will vary based on your machine, right? So whichever printer you use, run a few tests for tolerances and see how there's multiple ones online that you can use to really find what's the actual tolerance of your machine. 29.9 plus 0.25. So my opening will be 30.15 millimeters, and I will shift select, make them equal, and that is it. Close the sketch, and we're now going to pocket. And I said my lens is 6 millimeters, so I'll make a 6 millimeter cutout. At this point, this cover can be printed and used to cover the lens. Since I'm already in the process of building this, I might as well add a little bit of a personal touch to it. So I will jump to my bottom view or press 5. And I'll just add a few details to give a little bit of character. So we'll give it a bevel just to break that sharp edge. Okay. We'll start off with maybe making some eyes. We will constrain them to the same horizontal plane with H, so that way they can be on the same height. And we will constrain them together about 14. There we go. And then I'll constrain them to the origin, 7. And did not mean to do that. So R8, 7, and we will make them equal. And let's constrain it in a vertical position. So how about 2? There we go. So that's my eyes. There. How about we add some eyebrows? Right. I will constrain them to the eyes vertically. I'll constrain them both horizontally. There we go. Constrain them to this. There we go. So 2, 5. Oh, that should be fine. Now this one here will be equal, and this one will be equal. This one is not constrained this way, so vertical constraint. There we go, fully defined. Now I want to make this eyebrow slightly different. So I will remove my constraints for horizontal and vertical, and what I will do is we will select this, we'll take and make them perpendicular, we'll make them parallel with P, parallel, right? So what this does, now I can kind of rotate this. Now it's still undefined because I need to add a angle dimension to it, so let's do 20. There we go. I'm happy with that. Now I could do like a half circle for a mouth, but instead I'm gonna try something slightly different. How about we make like a little mustache? There we go, something like that. All right. A little bit, but I will actually close this loop right here, right, and I will trim away. I will trim the edge. I will select this and I will do symmetry. There we go. Now delete the edge. Now I want to make sure that these two are connected, and this just to, there we go. Now I will not try to define a sketch. I know that breaks my own rule of having a fully defined sketch, but it will take too long to just sit here and define every single point. However, I do recommend defining sketches or fully constraining your sketch. It helps it helps keeping the parts from falling apart later in the process when you start changing certain parameters of the part. Okay, so in this case, I'm happy with this. Close. Looks more like an angry face. Not, I mean, you could see it as a mustache or an angry face. You be the judge. Okay, let's pocket. And it gives us an error because it's trying to remove 5 millimeters of material when there's only 2 millimeters of wall thickness. So I will go for 8.8. That will give me about 4 layers of filament, right? 4-layer height. And there it is. So that is our lens cap. At this point, I'm happy with this. I will select the body. When you export the part, you want to select the body. And we will go and export this as our STP file. Now for 3D printing, the typical file format is STL. The BambuStudio accepts STP file. I prefer to use STP file because in certain instances, STL file will carry over these edges, and you can see there's multiple of these very short edges, and it creates this uneven surface. So I am trying to avoid it for the print. So I switch over to STP files. All right, so we are done with this, and we will jump over into our Bambu lab. And let's import our part. Just making sure it's fully okay. There's our face. Let's look at some parameters. So I will be printing a 0.2 millimeter thickness, so it will give us that 0.8 cutout for the face. Strength, I will print it 100% infill, because it's not a big part, but it will give us a little bit of extra strength in this bridge. So when I slice the part, there we go. Interesting. So the part will take about approximately 20 minutes to print. So we'll go ahead and just send it to our print. All right, so the port is done. I like how it looks. It has this interesting color with a little bit of specks to it. I really like how the filament lines align with, again, call it a mustache, call it the angry face with some teeth, but it really nicely aligns. So I think it came out really well. So, but an important part is to see how well it fits, really. So, just let's see how that gets on there. It's a little bit snug, but it is good because snug fit will prevent the dust from getting on top of the glass. So, and a little smiley face. The bevel I could have made the bevel slightly larger, but it's good enough for this. And it has a little bit of a character to this camera. So I am happy with this result. So thank you very much for sticking around. I hope you find this video useful. Thank you. Bye.